Hey everyone, this is Yogesh. And have you ever wondered what makes those big machines in the electrical substation, like these circuit breakers, so reliable? Today, in this video, we are going to dive into a really fascinating test which keeps them safe and sound. Don't worry if you are a seasoned engineer or just curious to know. I'll break it down in a way that is easy to understand. So, what exactly is a circuit breaker? It's like the superhero of an electrical system. Its job is to protect the system from faults by switching off the system automatically whenever the fault comes in, like short circuit or overload. But how do we make sure how they are going to handle these situations? So that is where the testing part comes in. By the way, if you haven't watched my circuit breaker video, then link is in the description. One of the most important tests for circuit breaker is called the dielectric test. Now, don't let that fancy word scare you. It simply means we are testing how well the circuit breaker can insulate against high voltages. Now, think of it like giving the circuit breaker an extreme workout. When it comes to the dielectric test, the circuit breaker faces two big challenges, almost like a superhero fighting with two big villains. The first one is power frequency voltage and the second one is lightning impulse voltage. So in this video, we are going to talk about these two challenges. So let's talk about power frequency test. This test simulates the regular voltage that the breaker will face in day-to-day life. Imagine you are lifting weights and you need to hold that weight steady for a minute. Similarly, in this test, we apply high voltage for a whole minute to check if the breaker's insulation is strong enough to hold up. If it is holding up and there are no breakdown and no sparking, then the test is said to be pass. Now let's talk about our second challenge, which is lightning impulse test. This test simulates those big sudden surges of voltage, just like lightning strikes or sudden switching in the network. Here in this test, the circuit breaker is hit with short bursts of extremely high voltages, which is usually much higher than regular voltage. Just like we are testing a car seatbelt by throwing it into a crash. If the breaker can survive these shocks, then it's ready for the real life electrical storms. So now let's talk about how we actually run the test. First, we place a breaker in the testing lab, either open or closed depending on what we are checking. Then after that, we apply the high voltage using a special equipment which could be auto transformer to the breaker's live and grounded parts. Okay, which is sound really intense, but it is all done in a controlled environment to ensure safety. Now, during testing, the breaker has to survive this high voltages for 1 minute in power frequency voltage test, and it must handle those high impulse shocks in the lightning impulse test. If the insulation holds up and there is no leakage current, then it is said to be pass. Now, why does this test matter? Imagine your home, your office, and your entire city suddenly losing power due to a fault. Now, in that situation, circuit breaker plays a vital role and they prevent the fault by cutting off the supply continuity. Now, in this situation, circuit breakers are responsible for preventing that from happening. The dielectric test ensures that they will protect the network and keep the electricity intact, and even in the most extreme conditions. So, to wrap things up, the dielectric tests are like safety check for circuit breakers, making sure they are ready for anything from regular voltage to sudden electrical storms. If you found this video interesting, then don't forget to like and subscribe for more cool insights on electrical technology. And remember, electricity powers our world, but tests like this that keep it under control. See you next time.